Hey guys, Miss Smith here. So we are going to do a quick quadratics review. So before spring break, hopefully you haven't forgotten everything that we did before spring break. So before spring break, we started working with quadratic functions. Okay, and so if you have me, we made jokes. I'm lame. It's fine. And you can make fun of me. It's totally fine because you're gonna remember it. So when you think about quadratic functions, I want you guys to think about Soulja Boy's math. So we're doing Soulja Boy's math because we're working with those U's, right? So we are gonna work with, or we're gonna figure out what are the things that we learned about quadratic functions. What are those characteristics of the parabolas that we learned before we left for spring break? So we're gonna review that because that's actually the first thing that we have to know for this. And for your final exam, we're gonna go back and you're gonna have to remember some of those things, okay? So just so you see your little image of Soulja Boy on here, when you see the word quadratic function, I need you guys to think of those U, okay, U graphs. And then real world situations, there are plenty of things. Throwing a basketball into a hoop, that is a quadratic function. The M's, so this McDonald's, right? So those are two parabolas, two upside down parabolas. You have monuments, bridges, like all of those things are made out of what we call quadratic functions or parabolic functions, okay? So let's review what we know about them, okay? So what are all those characteristics? So I'm just gonna kind of sketch some for a minute and we're gonna talk about different things and then we're gonna do one example, review a couple things, and then short little video just to refresh your memory. So hopefully you can get the first couple sections right on your work this week, okay? So all quadratic functions or all parabolas have a vertex. So let's say this was my parabola, okay? Ooh. So let's say that was my quadratic function. That's my parabola. It's really kind of messy, but we're gonna roll with it, okay? So that tip point, that very bottom point, or if it was upside down, it would be the very top point, is what we call our vertex. So right here, that is what we call our vertex, okay? And then we're gonna have an axis of symmetry. An axis of symmetry is gonna cut it perfectly in half, okay? So let's say it's gonna go straight through that vertex. So let's go ahead and call this 1, 2. We're gonna call that 2 right there, okay? So that we can say our vertex point for this graph is at 2, 0, okay? And then, so then we're gonna have an axis of symmetry. It's gonna cut that parabola perfectly in half. So let's cut it in half, but it's an invisible line. So I'm gonna dash it. And it's gonna be a vertical line. And when we learned Hoy Bucks earlier in the year, remember Hoy Bucks, right? With a V, so that stands for vertical, and that means that it has an x equals a number equation. So it's gonna be x equals, well, it's that x value of the vertex that it cuts through right there. So it's gonna be x equals 2, okay? Then x-intercepts. So we have to remember that x-intercepts have different names, okay? X-intercepts can be called x-intercepts. They can be called zeros. They can be called roots. Or they can be called solutions. Okay, so x-intercepts have 4 different names that we have to know all of them, okay? So on this one, there happens to only be one x-intercept, but there are 3 cases when we have quadratics. In this particular case, our x-intercept is that vertex point, so it would still be at 2, 0. Remember, all x-intercepts have a y value of 0. But sometimes with parabolas, so let's just sketch a couple graphs and look over here at these. Ooh, that's not a straight line at all. Let's see if I can do any better. A little bit. All right, so sometimes we might have ones that cross twice because they might look more like that. And it has 2 x-intercepts. So we could have 2 x-intercepts. We could have 1 x-intercept like our pink graph here. Or we could even have none. We could even have no x-intercept. So that one might look something like this. It never actually touches the x-axis. Okay, so we can have two x-intercepts, we can have one, or we can have none, okay? All right, and then we will always have a y-intercept. So y-intercept, man, I didn't do good in drawing my graphs where they had a y-intercept. So, but our y-intercept is where it's gonna cross the y-axis. So we have to remember that this is our y-axis, and so it's gonna cross that y-axis, and we'll review one of those in the next problem because it for sure has a y-intercept. But remember, y-intercepts all have an x of 0. Okay, and so then parabolas can open up or parabolas can open down. Okay, so we're working with our pink little graph right here. So we would say that it is opening up. Okay, and if our graph opens up, then we have a minimum, we have a low point. And so our minimum would be at this y value right here. Well, our y value of that vertex, the y value of the vertex happens to be 0. So it opens up, so it has a minimum, and it's at y equals 0. Okay, so it's gonna be at the y value of the vertex. Okay, so we have the y value of the vertex corresponds to that minimum or maximum. Okay, so then we also can find our domain and range. So if we remember, domain is all of our x values. So we can say how far left, how far right. Okay, so if we look, how far left did we go? Well, domain and range of any parabola, unless it's like a word problem or they give you like an actual chunk of a graph that has endpoints on it, then it's gonna go forever left because it has an arrow here, and forever right because of an arrow there. So it's gonna go forever left, forever right. So then that means that we would say our domain is all, let's write a little prettier. All real numbers. There we go. All real numbers. Okay, and then our range is the set of all y values, so our up and down. So we say, how low can we go? How high can we fly, right? So how low can we go? How high can we fly? Well, parabolas, because they don't go forever down and forever up, they have a minimum or a maximum, then that means that they're gonna open forever another direction. Or if they have endpoints, then you can see how low, how high. Okay, so this goes back to the beginning of the year. So if you guys have your notebooks, you've kept up with your notes, you should have notes on all of this stuff from right before break, and then we even did domain and range at the beginning of the school year. Okay, so hopefully you didn't lose those notebooks. Okay, so let's say if we were doing range, so we're gonna say how low can we go? Well, we go as low as 0, that y value of 0. And then how high do I fly? Well, we have arrows, so it goes forever up. So if something goes forever up, it goes forever up, then we would say its y is greater than or equal to, because y values are always getting bigger because it opens up. And that y value of the vertex, y value of the vertex was 0. So it would be 0. Y is greater than or equal to 0. But if it opened down, like the one over here on our example with 2 solutions, if it opened down, then it would be y is less than, because it's opening down, the y's are getting smaller, okay? So that's just our quick review. We can have 2 solutions, we can have 1 solution, or 0 solutions. So remember, solutions are x-intercepts, okay? It can open up, it can open down. It has an x equals a number, is our axis of symmetry, cuts it perfectly in half. Or vertex is that minimum or maximum point, okay? And our minimum or maximum is a y value. So let's try one more, review some things, and then call it good on this section, okay? So, all right, so let's look at this graph. So we have a vertex, we need to find our vertex. So, boop, found it. Okay, so we have a vertex right there. It is that lowest point that we see. So we have a vertex, and that vertex point is at 1, -4. 1, -4. Okay, then that vertex tells us a lot of things. The x value of the vertex corresponds with the axis of symmetry. The y value of the vertex tells us about the maximum, minimum, and the range. Okay, so that's an important point for us to find. It's a good starting place. Okay, so let's look at that axis of symmetry. So the axis of symmetry is that invisible line that would cut that in half. So we're gonna go boop, boop. It is that invisible vertical line that cuts it in half. And we might label that AOS, axis of symmetry. And it's gonna be X equals, that's how we write it as an equation. X equals, well, it's the y, or it's the X value of the vertex. It's the X value of that vertex. So it's gonna be X equals 1. That's the X value it cut through. Okay. X-intercepts, zeros, roots, solutions, all the same thing. Okay, so this time we have 2 of them, so we're gonna list both of them. Okay, remember we can have 2, 1, or none. Okay, so this time I have 1 right here, and I have 1 right here. Okay, so I have 2 x-intercepts. I have one at -1 comma, -1 comma 0, and at 3, 0. Remember, all x-intercepts have a y of 0, so we write them as a coordinate point or an ordered pair, okay? Now this time we have a y-intercept, okay? So we're gonna look at that y-axis, remember our y-axis, and we're gonna see where it runs into the y-axis, and it runs into it right there. So that would be our y-intercept. And all y-intercepts have an x of 0, so when we write that, we're gonna say 0, comma, -3. Okay. And then we have to decide, did it open up or did it open down? Okay, and so is it a U, is it a valley, or is it a mountain? Okay, so this one does open up again, opens up. And so if it opens up, then that means that it has a minimum. Remember, if it opens down, then we call that a maximum, okay? So it opens, our graph over here opens up and it has a minimum. And so then we say its minimum, we will say y equals, and it's gonna be that y value of the vertex. The y value of the vertex, that lowest y is a -4. Okay, then we have to find our domain and range. So domain are my x values. We say how far left, how far right. So how far left did I go? Well, there's an arrow, goes forever left. How far right? Goes forever right, has an arrow. So then we say that our domain is, let's switch colors. Domain is all real numbers. Okay, remember if it has endpoints, then you have to call those endpoints. So those would be stopping points. That's how far left and that's how far right. And then we look at those X values. And we'll review that again before you get to your performance assessment. But you have to make sure that you remember the arrows go on forever. Okay, so that's all real numbers. So then we're gonna look at range. Range is our Y, values are up and down. So we're gonna say, how low can I go? How high can I fly? Okay, so how low do we go? Okay, so we're gonna look at that Y value again of the vertex. Okay, so how low do we go? We go all the way down to -4. Okay, how to get rid of my line? There we go. Okay, so we go all the way down to the Y value of -4, and then it goes forever up. So if it goes forever up, then our range is going to be Y is, it's pointed up, so greater than or equal to, and that Y value is a -4. Okay, so those are our basic characteristics of a parabola. Okay, something I want you guys to see on here before we flip to the next page, which would be a really good page for you to screenshot so you can make sure that you remember, or if you're taking notes, awesome, keep doing that. Okay, so something that you need to know is that our vertex lies perfectly between these 2 points, between our x-intercepts. So if we're given our x-intercepts and we added those numbers together and divided by 2, we'd get the x value of our vertex. So like the number that's halfway between +3 and -1 is 1. And that's how we get our vertex. So if you're given your x values or your x-intercepts, then you can add those together, divide by 2, and you have the x value of your vertex. So just something to think about, okay? So here's your reminders, things to remember. What I just said, the vertex lies halfway between the x-intercepts, so you can find the x value of the vertex by adding the x-intercepts together and dividing by 2, okay? Then your axis of symmetry is written as the equation of a vertical line, so x equals a number, okay? Remember, x and y make a diagonal line. That's not diagonal, it's vertical, so only has an x, no y's, only an x. Okay, then x-intercepts are called solutions, zeros, and roots. And in real-world problems, our y-intercepts are our initial values. So when you see a y-intercept, then that's like your starting place. So like if I were to throw a ball from my balcony down to somebody on the ground, well, the initial height of that ball is going to be however high my balcony is. So then when I throw it, I have an initial height, and then it's going to curve and then go all the way down to the ground to the person. So we have a y-intercept as our initial value. So keep that in mind. Okay, so make sure you reach out to your teachers, you watch the next videos. If you understand our videos and you don't want to watch the Khan Academy, cool. But make sure you do your assignments and your practice problems, okay? Because that is making sure that you guys are ready for Algebra 2 next year. Because if you know these things, then you're going to be solid and you're going to jump in strong. We love you, we miss you, and we're going to finish this thing strong. Bye, guys.